Okay, so to illustrate what we've been discussing so far, let's start with an example, very simple example about a tiny project where a bank wants to establish a new marketing department in maybe a different city. And the project manager has already done his WBS, and he listed the activities as follows. So we need to help him to determine the precedence relationship. So this table that you see now is called a precedence relationship table, where you can see that we are listing all the activities, and we're going to specify for every activity what's its immediate predecessor. All right, why I'm emphasizing on the term immediate, because every or one activity can have so many activities that came before it, but there are few, or maybe sometimes only one, that is immediate predecessor, which is the one that just finished before that, and it's required for the next one to start. So what do we have here? I'm designating the activities with letter, because when we start doing the scheduling, it will be easy for us then to show these rather than to show the whole description. So we need to locate a new facility where you want to open this new branch or new department. And then we need to interview staff because we need people to work there. We are assuming that we are not moving people from the existing branch. No, we are hiring new people. So we hire new people, and then we want to furnish. So we select the furniture. We need to do some remodeling maybe, because the facility that we get does not necessarily satisfy our operations layout necessary for us. And then we will receive the furniture, we set up everything, and then we are ready to move in. All right, so let's do that together. I'm going to ask a question. Try to answer the question before you move on. So if you want, when I ask a question, just pause it, answer the question, pause the video, answer the question, and then restart the video to make sure that you have the right answer. So for the first one, A, does it have any immediate predecessor? This one I'm not going to give you time, because that's very easy. Of course, this is the first one. There's no immediate predecessor. What about B, interviewing the prospective staff? Do you think there's an immediate predecessor? The answer is also none, right? Because I can start interviewing while I'm searching for the new facility. So B does not have A as its immediate predecessor, right? These two are completely independent activities. They can go simultaneously. C, hire and train staff. What do you think? Of course, it has B as immediate predecessor, because first I'm interviewing these staff, and then I decide whom to hire, and of course then to train these people. D, select and order furniture. What do you think? Does it have an immediate predecessor? Yes, it has. It has A. Why? Because I cannot select the furniture until I see my new facility, right? Because otherwise, how can I select the furniture? Then remodel and install the phones. Of course, it also has A, right? Because when I locate my facility, I take it, and then I start remodeling. I do these remodeling works. Then receive the furniture. This is very straightforward, because of course it should come after selecting and ordering the furniture. So it has D as its predecessor. And finally, move in. This can be a little bit tricky, guys, for you, but think about it. All right. The answer here is not only F. Some of you may have answered F, because by logic, this is maybe the last one that's happened. This is when we receive the furniture. So now we are ready to move in. In fact, it's not only that. We cannot move in until we have the furniture, until we have installed the phones, because right, it's a direct marketing department, so you need phones. And what else? You have hired and trained your staff. So this activity has three immediate predecessors. It has C, E, and F. We're going to see next a graphical illustration of this project, which makes these precedence relationships even clearer for you. All right, once we have the precedence relationship table ready for us, as we did in the previous slide, now we're ready to do the scheduling, because we know which activity has to finish before the other activity can start, right? And as I told you, Gantt chart is a major tool used in scheduling. It's very, very powerful tool. So here you can see the format of a Gantt chart, where you have in the first column, you have a listing of all the activities. And here you notice that I added between brackets a number. This is the duration of each of these activities, okay, in weeks. Then all the other part, all that part, this is only a part of your calendar where you define what should be your time slot. For me, it's a week, right? So that's why every column here like that, this is 1 week. So this is week number 2, this is week number 4, etc. So let's do that. I told you also before that we show the duration of every activity using a column or a bar. So locating a new facility, it needs 8 weeks. So I know the length of it, that's fine. But when do I start it? I can start it immediately, right? Because it has no immediate predecessor. So I'll put it here. Just forget about these tiny gaps. It's only, this is technical. I could not reach the exactly at the line, so don't worry about that. Now, interview prospective staff. Also, we identified that one as independent. It's independent of activity A, so it can start immediately here, and it take 4 weeks. So here we go. Hire and train staff. Okay, this one has an immediate predecessor, which is this, right? That was C, and this is B. So C has an immediate predecessor. What do we mean by that? Again, remember, that means B has to be completed before C can start. So that's why I cannot start C here, for example, or here, or here. I cannot. I have to wait until this has completed. So that's why you'll see that this activity can start only here, right? And it take 9 weeks. 2, 4, 6, 8, and 9. 9 weeks. Now, select and order furniture. This has an immediate predecessor, which is A, right? This is A. And this is D. So D has an immediate predecessor A, which means D cannot start anywhere here, right? It cannot. It has to wait until A is completed, which is here. And now it can start only here, and it will take 6 weeks. All right, so again, 2, 4, and 6. Now, activity E, remodeling and installing, also has activity A as its predecessor. So it will also start at the same time as D starts, and it will take 11 weeks. Then we have receiving the furniture, all right, which is activity F, and that was E. Activity F has an immediate predecessor D, which means it has to wait until this is done, and it can start here. It takes 3 weeks. And finally, the last activity, G, moving in, has C, E, and F, right? So it has C as its predecessor, but it cannot start here because E did not finish yet, and F did not finish yet. In fact, G, even though it has 3 immediate predecessors, but what defines its start is the last one of the 3, the completion of the last one. And this is, of course, it's very logical, right? And this is why it can start only here, and it will take 1 week. So we can see, we can read here that this is the project duration, 20 weeks. All right, so I hope that was clear. Try to do it on your own. So I hope that you liked how we developed the Gantt charts. As I told you, it's a very important tool, guys. Um, you should be happy that you learned that here. And unfortunately, Gantt charts, they fail to reveal some relationships. I'm not going to go into details here. Really, it's not the time. Because this is only one chapter in this course, so it's really not the right time to learn more about that. But what you should know that it has some limitation, and that's why Gantt charts are used in conjunction with other tools where we use network diagrams. And in a network diagram, all the relationships are revealed very clearly, and this is what we're going to learn next. Okay, so we will start learning two tools that are globally used everywhere. Okay, these are called the PERT and CPM. It's either PERT or CPM. So PERT, program evaluation and review technique, and then CPM, critical path method. Okay, so they are used widely everywhere in the world, and they are very, very effective, especially for large-scale projects where you cannot really rely only on Gantt charts. Now, when you are using these, you'll be able to do the following. First, you will have a graphical display, graphical illustration of your project as Gantt chart does, but in a different way. You're going to see nodes and arrows. I'm going to show you in the next slide. Then you'll be able to easily tell how long will the project take. You'll tell what are the activities that are critical, meaning that if they are delayed, they will delay the whole project. So these are very important, and from that we're going to define a very important concept called the critical path. All right, so we'll do that in the coming few slides. So PERT and CPM use the graphical method, or in their graphical illustration, they use network diagrams. So what's a network diagram? It's a graphical representation of your project where you represent every activity in a circle, which we call a node, and the relationship, which is the precedence relationship among the different activities, are shown with arrows. So if you see an arrow going from one circle to another circle, that means the one activity is an immediate predecessor of the next activity. Okay, now there are two conventions used in PNDs, project network diagram. The first one is the activity on node, where you show every activity on any circle, as I showed you, or we have another convention called the activity on arrow, okay, AOA, where you show the activity on the arrow itself instead of representing the relationship. So activity on node looks like that. For example, activity A is an immediate predecessor of B, which is an immediate predecessor of C. So we show the activity inside the node, and that's why we call it activity on node. The other one, activity on arrow, is like that. The circle or the node represents the time or the point of time. Okay, so at this point of time, activity A happens. So we show that on the arrow, and it finishes on here on this point of time. And then activity B happens and it finishes here, right? So you see the difference among these two. In all the subsequent slides, we're going to show all our PNDs using activity on node. So this is the convention that we use in this topic.